Okay, we'll just begin then. It's just past 2 o'clock here. So my name is Mackovski, and I'm the Scientific Support Specialist with ADInstruments. And today we're just going to be covering the new product in our line, the PowerLab C. Going in a bit more depth in this webinar specifically, so you have a really good understanding of what it's capable of and how you can apply it with your existing system. So what is the PowerLab C? Well, it's actually a whole new design of the PowerLab. If you're familiar with the PowerLab or our products, you remember the B and C connections at the front of the PowerLab. That design itself hasn't changed in decades. And what we've done here is a totally new redesign to really be updated with the new digital world. It's based off modern digital architecture, and it is comprised of a series of devices, not just one, but multiple devices here. And essentially, it's just meant to replace PowerLab that we know. So there are a lot of advantages of the system, but it still provides what you need for the PowerLab at the same time. So the C series is actually divided into 3 separate products. The first, you may remember these B and C connections. This is our instrument interface. So what you can see here, what actually connects to these are devices that just need a B and C connection only. So anything like a transonic flow meter, or maybe a Miller MPVS, or maybe some sort of Werner devices. Anything like that requires a B and C connection that's not part of our product line, typically requires a B and C connection. That then connects to this instrument interface. The reason why it looks so small is actually, well, I'll talk about this later in the webinar, you can actually connect this directly to your computer. You don't even need mains here. You can actually go right to the computer and that'll work. So this way, I'll be using this word quite often in the webinar. It's modularity, and this is exactly what its purpose is for, just modular system to connect to your computer. As you can see here, so B and C connection, transonic device. Another option here is a front-end interface. So this is connecting actually to our front end. So maybe things that you will be familiar with, a bioamp or a bridge amp. It could be a gas analyzer, a neuroamp, etc. Anything like that. It's a front end that you would normally connect to a PowerLab. But what you can do here instead, as mentioned with the instrument interface, is modularity again. So this would actually connect to the back of your front end, and you can actually connect this directly to the computer. So you don't even need mains power. You can just connect it up and it'll work via this USB-C connection. So that's what we mean by modularity there. Whether it's an instrument interface or a front interface, either one of these are effectively still a PowerLab. So when you open up LabChart, it'll look identical. You'll still be able to collect the same data. It's just a much more modular version of that system. However, when you're using multiple of these devices, that's when the PowerLab C would come into play. So the purpose of the PowerLab C is to provide synchronization between devices and also be able to deliver power management, a new universal way of doing that. And I'll talk about it a little bit later on in the webinar. So we've got a modularity system going on here. You can either use the instrument interface for certain analog specific instruments, or front interface to connect your front ends to either to the computer or to the PowerLab C. So the C series main features, as I already mentioned here and will continue to mention, is one thing is your analog compatibility. The system itself, we understand, we're not trying to make something that's totally new that requires a whole new system from your end. So we understand we require analog compatibility, and that's exactly what we're doing here. So that way, your old front ends can still work with this system as well. Even your PowerLab, your older PowerLabs, they can still work with C series. So that doesn't mean that you require a whole new upgrade. It just means that we have compatibility there. At the same time, we're providing a future-proof design. The design itself looks ahead for devices that connect to our PowerLab using digital technology via USB-C. So examples of those is you could effectively charge other devices, so maybe your laptop or maybe your camera or something like that. It's able to connect these systems up and charge them to PowerLab C if you wanted to. But as this is a whole new system itself, the future-proofing enables us to come up with new designs of products that connects directly to PowerLab C. So this is just providing the baseline for future devices. Another big advantage of the system is it provides a sub-microsecond synchronization. So this is very important for nerve conduction studies that require high sample rates, so maybe 10 or 20 or even 100,000 samples a second. By applying this, we are having absolute accuracy in your data. As mentioned earlier, this is a modular system as divided into either the front-end interface, the instrument interface. This way, you don't require your PowerLab if you don't necessarily need it. We understand that if you look at purchasing, a PowerLab like a 35 or a 30 series, you may only be using it for one specific goal, but you may not be actually utilizing all of the features on the PowerLab. So that's the whole purpose of the modular system. You're purchasing only what you need. But if you have multiple devices, that's when we use the PowerLab C that can not only charge everything, but also provide that accuracy with the synchronization. Because these are modular, it then provides portability with your system as well. So the PowerLab C, as mentioned, that this actually has 3 ways it can be charged. So the 35 series, that's right, or even the 26Ts, for example, they all require mains connection, okay? Here, you can apply mains, but you can actually also power the PowerLab C either through a power bank or even your computer itself. So that way, there's less cables for you to play with, and it's a more simpler system to work with. And this simply is using the USB PD technology. This is a power delivery technology I'll be talking about later on in the webinar. So what this power delivery technology does, in essence, it can deliver upwards of 100 watts on a device if required. And that's a really big leap forward in technology. So in comparison here, you can see that this is the typical 35 series we have. So you have all the B and C connections, the front, the DINs, you have your trigger there, your pulses, usual suspects here in the 35 series. With the PowerLab, it's much cleaner. I mean, where all the B and Cs are not there at all. I mean, everything, the business end of this system is actually in the back. All the connections in the back are USB-C connections. And that's what we're talking about with the evolution of this design, that we're future-proofing it, because we understand that USB-C, it's a universal connection that is not only connecting laptops and phones, even cameras, etc. They're all using USB-C technology. So this is the reason, one of the main reasons why we move forward in the system. Compatibility. This system itself is compatible with LabChart 8 and LabChart Lightning. That's our new evolution of LabChart. It's not unfortunately compatible with LabChart 7. So those are the 2 ones that work. It doesn't matter whether it's Windows or Mac, it'll work the same either way. As mentioned, as you can connect these to your existing systems, that's totally fine. So if you had already a system set up, you can purchase a C series devices and expand on your system, and they will both work synchronously with no problems whatsoever. It just means that both systems require a separate USB connection to your computer. So an example here of expanding your system is, let's just say you already have a 35 series PowerLab or something similar to this. Connecting, all we just want is a USB-C connection to your computer, but also one from the PowerLab to your computer. So remember, as I mentioned to you, even if we don't use a PowerLab and just had like a front end only or an instrument interface, these both can connect to the computer anyway. You don't have to use a PowerLab. But the point is that both of these require separate USB connections to the computer. This way it enables them both to work harmoniously within LabChart. So you wouldn't notice any sort of delay between signals. But we do recommend when doing this sort of a system to keep them on the same hub. So a same hub would typically mean putting them on the same side of the laptop. So let's focus more on the individual devices themselves. So the first one we're talking about here is the front end interface. So remember, this is connecting to our front end. So things like that we supply, bioamps, bridge amps, neuroamps, gas analyzers, that sort of thing, just front ends. What this does is that this will connect directly to the back of the front end. So you can see here we have an I2C port. I'll be showing that in the webinar how to connect it. And on this side, this is the back view. We just have an analog connector and a USB-C port. So the two cables here, the USB-C to USB-C connection. So this is actually supplied with the FEI and also with the analog cable as well. So this cable, you can see one side will connect to the FEI side and the other side will actually connect to the output of the front end. And I'll show you some images of those soon. As mentioned, this is effectively a PowerLab. So once you connect that to your front end, you can plug that into the computer, it'll behave exactly the same way. So that means we can run up to 8 channels here at 50 kilohertz or 4 channels at 100 kilohertz there, so high sample rates. It can support new and obviously legacy front ends. And as mentioned, right here is analog cable for 1, but there can be a variation of 1, 2, 4, or 8. So if you're using like an octal front end, like an octal bioamp, an octal bridge amp, as an example, we have one with 8 BNCs and then 1 analog cable that will connect to the front end interface. So it doesn't matter what size the front end is, this will always be the same front end interface that connects. The variable would be the size of the analog cable. So how do I connect a front end? As mentioned, so how we would do that if this is your front end here, we will just connect the front end to the I2C port as shown. We have these little screws here to secure it in place. And then we'll connect the analog cable as shown and a USB-C connection that can go to the computer. So as you can see in the image here, that's the right connection we want, a USB-C connection. So we don't want to be using USB-A connections with this sort of a system. The primary reason is the USB-C connection delivers a lot more power needed to run this front end. So that's the reason why. The only time there'd be a limitation is if you're doing octal front ends or multiple front ends, that's when we would need the PowerLab C. But if you're just using one front end only, then there's no reason why you just can't connect this to your computer as long as it's a USB-C, and it should work, provided it's a single front end. So here's an example of a bridge amp. It could be any front end, as I mentioned, apart from octals, but you can see the front here. Normally we would have a PowerLab connected to the bridge amp, but as you can see with the front end interface connecting to the back, we just have 2 cables. We have the analog cable, as you can see, and then the USB-C cable connecting directly to the USB-C port. So it's a much cleaner system to work with. This is what I mentioned about modularity. You could effectively have this system isolated, which means you can have the laptop on its battery, and then this is being charged from the laptop, and you have a totally isolated system. So this way it's very portable for you to work with. Here's an example with a quad bioamp. So you can see here, just it's a very clean system, no PowerLab required. And the back is just a front end, 1 USB cable here. So this cable can come either in 30 centimeters or 1 meter in length. And that will just connect to the USB-C connection to your laptop or whatever device, whatever computer. And you can see the analog cable, instead of having 1 analog, now it's 4 because it's a quad bioamp. So either way, it'll work out for you. So a common question is, well, why can't I use the USB-A? I mean, it's right there. Why not? So the reasoning is because the USB-A ports just don't deliver enough power to run the front ends. USB-A type 2 or type 3, I mean, you don't have to remember these numbers at all, but just we just have an understanding that they can deliver 2.5 or 4.5 watts respectively. But front ends, whether it's a bridge amp or a quad bridge amp or even that sort of stuff, they require at least 7.5 watts or 15 watts to run. Okay, so you can see here the USB-As, they just have that much power, but they require at least 7.5, 15 watts to run. So to achieve that, we use USB-C ports. So you can see down here is a USB type C it can deliver up to 15 watts of power. You can see the 5 volts times 3 amps. So that's what we're talking about. And then we have a USB PD. I'll talk about that a little bit later on, but you can deliver a lot more power with that port as well. It's the same sort of system, but just a slightly different technology there. But that's the reason why we should only use USB-C ports when connecting a front-end interface. If you don't have a USB-C port, that's when you require the PowerLab C, because then that connects to a main system, mains power, and then the system will work as intended. So even if you don't have USB-C, the PowerLab C can do the job for you as well. So let's move on to the instrument interface. This, as mentioned to you, these are just analog connections. So these typically connect to other devices that aren't ADI related specifically. So there's 4 BNC connections. Each one can do up to 100,000 samples a second, and it's intended to using for analog instruments. So you can see down here, we have a transonic system. So this is used for measuring blood flow. There's just an analog cable connection here that goes to the BNC of the instrument interface. And like the front end interface, this just connects to your computer. So once again, you don't require mains here for this system. Obviously you do for the transonic, but for the instrument interface, that can just connect to your computer directly. Same thing with the Miller MPVS. If you're like doing a mouse PV loop study, all you need to do is just connect these up, have one USB-C connection going directly to your computer. This way, it's a much simpler system to work with. You can see in the photos here, because it's an instrument interface, we only have one port, and that port can connect directly to your computer, or that can connect to the PowerLab C, and I'll show you how to do that later in the webinar. So here's a above view. So it's a very simplistic system to work with. Let's move on to the PowerLab C here. So the PowerLab C, as mentioned, is required specifically for multiple devices to be connected. And when your device is simply just, are too large to be connected to the, if you don't have like a USB-C as an example. It enables sub-microsecond synchronization between your devices and enables main filtering. So that's something I did mention to you, that mains filtering is required to remove mains noise, so like 50 hertz from, to your signal. And when you're just using the front end interface by itself, that mains noise will be there, but when connected to PowerLab C, that mains noise can be effectively removed. So that's similar to what you can see with your original PowerLabs. Everything in the back is USB-C cable links, as you can see, just USB-C cables, and can be connected 3 ways, either through mains, the most common way, auxiliary power, which is a power bank, or computer, which requires USB PD. So that means it delivers high enough power to run the whole system. So you can see here we have a couple of front ends. They're just connecting to the PowerLab C here. So the PowerLab C, as mentioned to you, is a C series compatible. It's compatible with C series devices and has 4 downstream facing ports. So you can see these are the ports. So any front end, any instrument interface, or any other device that requires power connects to one of these 4 ports. These are downstream facing ports. You can see the mains connection here, and how this all works together is by using USB PD. So what that means is that this new technology that's been around for quite a while now, it allows power from a source device, meaning the PowerLab C, to negotiate the power required for the other devices to function. So if other device required, 2.5 watts, it'll deliver 2.5 watts. Or if another device requires 50 watts, it'll deliver 50 watts. Or even up to 100 watts, it can do that. Either way, it can deliver the amount of wattage required in that negotiation, all off the same USB-C connection. So you don't have to change the cables. They're all off the same USB-C cable there. So the USB-C has a power budget of 310 watts. It's able to deliver 310 watts out of those 4 downstream ports to any of the devices. So it gives you plenty of power to work with there. So you can see them here in the high resolution image, the 4 downstream ports. So here's just a bit of a more of a graphical representation of the work of the connections there. So in orange are the downstream facing ports. They can be either front end, so remember that connects to a front end, like a biamp or a bridge amp. So that's your front interface. Here's your instrument interface. Here's another front end. Or you can actually daisy chain the PowerLabs together. So if your system requires more than 4 ports, so more, if you have multiple front ends, as an example, you could daisy chain one PowerLabC to another, and then that PowerLabC has an additional 4 ports. So that way you're able to increase the amount of ports required. The bottom here in red are our upstream facing ports. So this is actually delivering power to the PowerLab. So whether it is, as mentioned, there are 3 ways to power this. You can be through mains connection, which you don't see here, which is just cropped out, or the auxiliary power, so power bank, or of course via the computer. But it's important to know though that regardless of the way you power it, we always have a connection from the computer to obviously your computer here. That way it's able to have LabChart running for you. So remember, these are downstream facing ports. It will connect to any device. And then to connect to the computer, we'll connect to this to the computer. And you can use either powering for the mains or even for the power bank here. So here's an example of a photo where it was just one bridge amp as an example. So before we had a bridge amp connected directly to the computer, but if you didn't have a USB-C port as an example, this is how it would look. So it looks very clean from the front. As mentioned, there's no BNCs or anything like that. So that way, it's a very clean, simplistic design here. So the back of the port, you can see similar sort of principle. We have a front end interface connecting to the bridge amp, as you can see, and then there's 2 cables. You've got the USB-C cable. So remember that would connect to the computer, but in this case, this here runs all the way around to connect to the downstream facing port. That way, the power is being delivered to the front end. And then we have a computer cable that goes directly to, of course, the computer. So you can see how that looks. So here we could actually connect 3 other devices and it'll all be synchronized and being able to be fully charged based off using the mains power. Here's an example with an octal bioamp. So once again, it looks very simplistic from the design. No fuss. All you're focusing on is the front end, and the back, as mentioned, is just a front interface. And this time we're just using one analog cable that has 8 BNCs. Remember the previous slide had 1, now this has 8. And of course, we have one USB-C connection that connects directly to our downstream facing port. And of course, the computer cable goes directly to the computer. Here's some more high resolution photos for you. It doesn't matter really which way you stack them. So we have just an instrument interface here and a front end interface, both connecting to the downstream facing ports, as you can see. And then we have the computer port that will go directly to the computer. So this sort of a design actually would require a mains or a power bank, but you just don't see it connected here. But that's how it looks. So from the front, it's a really simplistic look. So all the USB-C cables, as you can see, they're all the same. They just connect to your system via the downstream facing ports. So a bit further discussion about the isolation aspect of this system. If you didn't want to connect to mains, you could effectively connect a power bank directly to the auxiliary port instead. So what they will do, they will run not only the PowerLabC, but any front end as well. So that's how it would essentially work. But it's important to know though, not any not any power bank will work. It requires a power bank with a USB-C connection. So you wouldn't be using a USB-A, as you can see here. It just won't deliver the power. So if you see the words like USB PD on your power bank, or just at the very least a USB-C, it'll also tell you how many watts can deliver. So, I have one here that can give me about 60 watts, and that's more than enough to run not only the PowerLabC, but multiple front ends as well. So as mentioned, USB PD technology can deliver up to 100 watts. So if you have a pretty new power bank, you could actually deliver 100 watts to your system. So that way you don't have to worry about mains, but also more importantly, it isolates the system. So that can be pretty important for quite a few studies that require connections to humans. So that can definitely bypass it. And I'll mention this will be a modular system as well. So that's just using the auxiliary port. And finally, we're talking about here is daisy chaining. So if 4 ports is not enough, what we would do instead is that, let's just say these 3 ports were full. Our 4th port then would connect to the computer of the second USB, the second PowerLab C, and now we have 4 additional ports to work with. So these are both synchronized together, as you can see, and then that way we have, essentially in this sort of a setup, would have 7 downstream facing ports to work with if it was a more of an advanced system. So you could actually keep adding more PowerLab Cs to this. So that's really not a problem at all. As mentioned, of course, this would require a mains connection, and then it shouldn't be a problem at all. So you can see there that we would have from the downstream facing port connect to the second PowerLab C, and now they're both synchronized together. So that is basically an overview of the system itself. You can see that I do have 3 of the devices in front of me. We've got the PowerLab C, I've got the front-end interface, and I've got the instrument interface. So if you have any questions, please ask me now. As mentioned, well, I did mention actually, but this is of course recorded, and I will send this webinar to all of you. And if you have any questions regarding the devices, I'm happy to answer them or forward you to our local sales reps. But you can see here that it's a very slender device itself. We just have our I2C connection that will connect to your back of your front end. And then we would have at the front here, would have the USB-C and the analog cable as well. So that's the front end interface that will connect to your front ends. And of course, if you just have, analog cables only, then you can just connect here analog to a BNC connection directly to your computer via the USB-C ports. It's a really minimalistic design here. So it's meant to be easy to work with. So the whole purpose of it is in that way, very simple system work with no connection to the front here, not required, just has a status light and power light. Then of course the back is just you have all of your USB-C connections to work with there, as mentioned in the webinar. So if you have any questions, I'm happy to answer anything now, and otherwise you can contact me. So I'll just wait a minute or so if there are any questions. So while I'm waiting for any questions, if you don't mind typing anything out, I might just connect one of these up for you to show you how simple it works. So this system here with a bridge amp, as an example, this can be a single, dual, or a quad, doesn't really, or even octal, doesn't really matter. Obviously the octals won't work directly to the computer, but how this would work is we connect this here to here just by that system like that. The screws in place, just like that, very simple. And then we would have our USB-C and our analog cable, and that's it. Really simple to work with. And then from here, we're good to go. That's basically it. So from here, I can essentially connect that to my laptop if I wanted to, and then really I'm good to go. So no real messing around with mains connections here. It's a very simple system to work with. That's the modular system that we're talking about. Otherwise, I could just take this off, connect this to my PowerLab C, and then that will essentially work as well. Right, doesn't matter. From here, then I'll connect this to the computer, and that'll work. So you can have 1, 2, 4, or multiple front ends, and that's the whole purpose of the modular system we have here. So yeah, any questions at all? Happy to answer them. As mentioned, it works with LabChart 8 or LabChart Lightning. And yeah, it shouldn't have any real problems at all. One of the biggest advantages of the system that I personally found recently was that we had a device that required multiple octals. And if you had a 16-channel PowerLab, it just wouldn't work. There'd be too many BNC connections. But because each octal bioamp or bridge amp will just connect to one USB-C connection, it actually effectively reduced the amount of clutter on the table. So it's very simplistic working with the system. Got one comment here. Neil Ward, can you connect into ClearCloud LT? very good question. I will have to follow up on that one, but I know for a fact that you can connect other PowerLabs to your to LT. That shouldn't be any problem. If people are not aware of LT, that's our online learning platform. Normally we use 26Ts, as you'd be aware, Neil, but you could effectively, I don't see any reason why it wouldn't connect. I'll definitely get back to you on that one, but it would connect the same way. It's just that we'd have to worry about the channel configurations, but I definitely don't see that being a problem at all. So I'll definitely get back to you on that specific question. Thank you for that, though. Very good point. Okay, so if there's no other questions, then that's totally fine. You can just contact me and I will respond back to you with any sort of answers with the PowerLab C. So thank you again and have a good day. Thanks. Bye-bye.